This is Mr. Smith with the Honors Economics Unit 3, the first lecture, which is about elasticity. And that's what we'll be looking at today. This corresponds with Chapter 5 in the digital check textbook. And elasticity, just to give a brief introduction definition, elasticity is the flexibility of either demand or supply in reference to price change. So how much is the quantity supplied or the quantity demanded of a product going to change with prices? And some products are not going to change that much, and so they don't have a lot of flexibility. And so if they don't react a lot to price changes, they're known as inelastic. If they do reflect a lot on price changes, they're incredibly flexible. They're known as elastic. Pretty simple. So we'll talk about both elasticity of demand and supply in cases of elasticity, and pricing, how that causes an impact, and in other areas as well. So elasticity, once again, is the measure of responsiveness of one variable in a change to another variable. In the case that we'll be talking about here, will be quantity and price. Price elasticity is the ratio between the percentage change in the quantity demanded or quantity supplied and the corresponding percent change in price. Price elasticity of demand is the percentage change in the quantity demanded of a good or service divided by the percentage, and the price elasticity of supply, the percentage change in quantity supplied divided by the percentage change in price. And so we can see an elastic demand or elastic supply, and one in which elasticity is greater than 1. So when we look at that, we can tell this involves a mathematical formula, because if it is greater than 1, it is reflexive of price change. If it is less than 1, then it is inelastic, so it's not that reflexive. And so the greater the number over 1, the more elastic it is. The lesser the number is than 1, the more inelastic it is. Unitary elasticities indicate the proportional responsiveness of either demand or supply. So, in other words, the price change went up and the quantity changed, but not enough to correspond a noticeable difference to the firm. And we'll talk more about that later. So there we can see down at the bottom the percentages written out. The percentage change in quantity, if it is greater than the percentage change in price, then you have what is called the actual formula. The percentage change in quantity divided by the percentage change in price is greater than 1. It is known as elastic. And if the percentage change in quantity is equal to the price, then you can see when you divide the quantity by price, you get a number that is equal to 1. That's known as unitary elastic. So the price change is not going to create a noticeable difference in quantity. The quantity will change, but because maybe you're selling a little bit less, but you raise the price a certain amount, so you're still going to be bringing in the same amount of money, it's not going to result in any noticeable change. So that would be unitary elastic. And then the percentage change in quantity, if it's less than a percentage change in price, and you get that by dividing the quantity by price and getting a number that is less than 1, then you have something that is inelastic. And another way that you can see this written, by the way, is with the Greek symbol delta, which is a triangle. So you might see that everywhere where the word change is written. And to calculate elasticity along a demand or supply curve, economists use the average percent change in both quantity and price. So the midpoint method of elasticity is the percentage change in quantity and the percentage change in price. We need both of those percentages. And so you can see they take the second quantity and the first quantity, you subtract the difference, and you divide it by, of course, those two added together divided by 2, which is the average, and take that times 100, basically, to get the whole number. And then the percentage change in price, you do the same thing. You take the second price, subtract the first price, and then divide it by those two together, those two added together divided by 2. And so remember, they're doing two things here. Basically, they're getting the averages, and they're dividing the difference by those averages in both of those cases for the midpoint formula. So calculating the price elasticity of demand. The price elasticity of demand is calculated as the percentage change in quantity divided by the percentage change in price. To remember, here's an easy way to remember it. Elasticity is always Q over P, Q over P, Q over P, Q over P, Q over P. So just remember that you have Q over P, and you'll be fine. Because sometimes a lot of times when students try to calculate elasticity, they get it mixed up. But remember, it's Q over P. So elasticity of demand, we're going to look at this specific example using that formula. And we're looking at points A and B here. And so this is a demand curve. Following the law of demand, obviously, the price is high, quantity is lower. Price is lower, quantity is going to be higher. And we're looking at the change from these 2 points here. And so the change in quantity, we're going to subtract the difference. The quantity is 3,000, and then it's 2,800. So we're going to subtract the difference. On top of this division problem, on the bottom, we're going to take the addition of these two divided by 2 for the average. So we're going to end up with a 200 difference. The average is 2,900. So 200 divided by 2,900 times 100 to get a whole number, and we get 6.9. Then for the change in price, because remember we have to do that too, and that's another thing students sometimes mess up on, is they do 1 and they say, oh, we have a number, 6.9. That must be the answer. But that's not the answer. That's only part of it. So now we have to get the percentage change in price. And so the percentage change is 60 minus 70. And so that's a negative 10 difference, and negatives aren't going to necessarily matter here. And then we have 60 plus 70 divided by 2, which is the average. And so we have negative 10 divided by 65 times 100. And so that's going to end up with a number of 15.4. So remember, we have Q over P. So that is the actual elasticity formula, 6.9 divided by 15.4. The elasticity of demand between these 2 points, the answer is 0.45, an amount smaller than 1, showing that demand is inelastic in this interval. And there is a little bit of steepness to this slope. If it was a little bit flatter, maybe that wouldn't be the case. And so we do have what is known as an inelastic product, because this number, 0.45, you can't see it down here, is less than 1. In supply, we're going to do basically the same thing, except we're looking at the supply curve, and we're looking at 2 different points here. The price differences is going to go from 600 to 700, and then, or excuse me, 650, because it's actually in between those 2 points. And we can see that the quantity was originally here, and it's going to change over here. And this is in thousands of units. So make sure that you always pay attention to what exactly the tick marks are going to actually stand for, because it isn't just 10, it's for 10,000. So if we see the percentage change in quantity, we go from 10 to 13,000, or 13,000 to 10, we subtract the difference, that's 3. And we divide that by the average between those two. The average between 13 and 10 is 11.5. And so we divide 3,000 by 11,500 times 100 to get the number for the quantity, which is 26.1. But then remember, we have to do the same thing for price. So 700 to 650 is a difference of 50. The average between the two is 675. 50 divided by 675 times 100 is 7.4. So we have the elasticity of supply. Remember, we still have to calculate that. We haven't done that yet. 26.1, the quantity over the price, Q over P, Q over P. And so the answer is 3.53. So that is, of course, over 1. So the price elasticity of supply is calculated as the percentage change in quantity divided by the percentage change in price. And so this is going to be greater than 1. So this is an elastic supply. So what does that mean? If this is the same product, it means that people are not that flexible when it comes to their demand. If the price goes up some, they're still probably going to buy just about as much. But if the price goes up some, the law of supply kicks in, and companies are going to want to make more of this product. Well, apparently they can do that pretty readily. If the price changes, they can start supplying more. And so this is a good product for a company to sell, one that people are going to buy even if there's a price change, but one that you can increase your supply of if the price goes up. So polar cases of elasticity. Infinite elasticity, or perfect elasticity, is what it's called, is either the quantity demanded or quantity supplied changes by an infinite amount in response to any change in price at all. In both cases, the supply and demand curve are horizontal. The quantity supplied or demanded is extremely responsive to price changes, moving from 0 for prices close to P to infinite when price reach P. And there you can see the horizontal curves. Zero elasticity, or perfect inelasticity, is when a percentage change in price, no matter how large, result in zero change in quantity. And they're represented by a vertical line in both cases. So you can see they're just straight up and down. Constant unitary elasticity in either supply or demand curve occurs when a price change of 1% results in a quantity change of 1%. A demand curve with constant unitary elasticity will be a curved line. Notice how the price and quantity demand change by an identical amount in each step that occurs. And when this happens in a supply curve, it's a straight line. Between each point, the percentage increase in quantity demand is the same as the increase in price. And notice that here as well. Something I'll mention, though, going back to these, is when we talk about perfect in economics, when we're talking about human beings and their rationale in purchasing activities and production activities. So there is no such thing as perfect. So this is just a theoretical example of what it would look like. This doesn't actually happen in reality. So when it comes to elasticity in pricing, we have to consider, of course, if we're a firm, for instance, what is the elasticity of demand? Because obviously a change in price can impact our overall bottom line if we lose lots of customers. So most businesses face a day-to-day struggle and try to figure out ways how to lower costs and keep their prices at a good level that are bringing enough revenue and making sure that they're not scaring away a lot of customers. However, in some cases, the price of a key input over which the firm has no control may rise or fall, so their production costs can change. And so what do they do then? If they have a product that is incredibly elastic that they're selling and their production costs go up drastically, what do they do? And of course, they rely on the fact that maybe the rest of the market is facing the same conditions, so all the businesses will have to raise their prices. But that obviously becomes a very tenuous decision to make. A lot of people, when they see the price go up of a product they like, they say, oh, how can they do this? But a lot of thought goes into each of those changes. So can a business pass their costs or cost savings on to consumers? And it depends upon, of course, how elastic the price is. And looking at elasticity for different goods and services, housing, for instance, is obviously going to be incredibly inelastic. People are going to be willing to pay a lot in order to make sure they aren't shoved out onto the street. And so elasticity is typically below 1. It's about 0.12. Air travel, surprisingly, because if you are traveling frequently, you have to because of your business. And so that can have inelastic price. Of course, that is just transatlantic air travel. It's not going to be the same for Pacific travel. And this is for economy class. It's not the same for traveling at higher priority, like first class, for instance. That's more of a luxury, so that's going to be more elastic. Rail transit, because a lot of us don't ride the railroad, but in places where it exists, it's obviously a necessity, and so it has a low elasticity of 0.15. Electricity, 0.20. Taxi cabs, once again, you don't have a car. In some towns, that's the only way you can get around, so 0.22. Gasoline, unsurprisingly, 0.35. Then they'll look at this one, transatlantic air travel. I said it's more of a luxury. So it's not going to be as inelastic, but it still is inelastic. It's 0.4. But notice the difference between first class at 0.4 and air travel economy class 0.12. Then we have, surprisingly, wine, because people apparently believe it's a necessity. Beef, which shouldn't be a surprise because that's one of the greatest amounts of meat that is eaten in the United States. Transatlantic air travel for business class is 0.62. Kitchen and household appliances, 0.63. You need to have a fridge. You need to have a stove. Cable TV, for some odd reason, people believe that this is necessary, so 0.69. Chicken, 0.64. Soft drinks, why? 0.70. Beer, why? 0.80. New vehicle, 0.87. I mean, there are a lot of things here that aren't necessary, but people apparently are willing to pay more for because for wine, they believe it makes them sophisticated. A new car, it's a simple status, it's not going to break down, it's trustworthy. So there are other reasons that can feed into why people think it's a necessity. When we get above 1, though, computers. surprisingly. I think computers will be a lot more useful than anything else. We can separate cable TV. The one I mentioned earlier was for rural areas because maybe there's not a lot else to do. So they're more likely to believe it's a necessity. But in an urban area, that's not the case. Cable TV is actually above 1. It's 1.51. Restaurant meals is 2.27. So you can see the elasticity increasing there. The higher the number, the less necessary it is. So you can see all the things that influences this. Interpretation of necessity, of relationship to your day-to-day life. Do you need this air travel for business, for instance, to actually get back and forth, or rail for that reasoning as well? Is it? Do you have something else that can substitute this in a cable TV in a rural area? Apparently, no. There isn't a lot else you can do, and so it's perceived more as a necessity. So it depends upon other variables that can influence whether or not this product is elastic. So does raising price bring in more revenue? Well, that's a good example. It depends on how elastic the product is. The more elastic it is, the higher that number is above 1, then the chances are that raising the price might not make you that much money because you're going to be losing customers. So if demand is elastic at the price level, then you should probably cut prices because the percentage drop in price will result in even higher level of increase in quantity sold. And so the more elastic the product is, the lower you should try to keep your prices. The more inelastic a product is, the higher you can keep your prices. But that, of course, is only taking consideration elasticity of demand. So can businesses pass costs on to consumers? Most businesses face a difficult decision when their ingredients or the materials go up in price. So if you do have your prices go up for the material that you need to make your product, how much can you pass along those costs to the consumers? Well, that should be pretty easy. Obviously, if you're in an elastic type of business, that is your product that you're selling has elasticity when it comes to demand, you're not going to have as much flexibility in passing along those costs. However, if your product is inelastically demanded, if people aren't flexible, they have to keep buying your product, then you can pass along more of those costs to the consumer. And despite thinking that way, when we plot this out mathematically, we can see see a result that is kind of surprising. So for instance, on the left-hand side, remember that inelasticity is when you have this steeper slope. Elasticity is when it's flatter and when there's less of a slope. So we can see that when a new technology, for instance, is introduced for an inelastic product, if we're moving it about the same distance here, you can see that the new supply curve, which is S1, has a much lower price that you can possibly pass on to the consumers. And then when we have an elastic product, the supply, even though you're changing the quantity quite a bit, you are going to have not that much of a price difference. So mathematically, when we plot it out, you can see it doesn't work out the same way that people might think. However, does that mean you can get away with keeping your prices higher in this case? Well, it depends upon the other firms and what the marketplace does overall. And then, of course, there's higher taxes. If you're selling a product like cigarettes and the government wants to tax it, then it's going to cause the price to go up. And cigarettes are obviously an inelastic product because people who are addicted to it believe that it is a necessity, at least their bodies do. And so they can raise the price, but you can see that the quantity demanded isn't going to change that much. People are going to continue to have to buy it. And so you look at a much higher price, but you don't have really that much in a drop in the quantity demanded. It's just going from Q0 to Q1. However, if the product is elastically demanded, then that tax is definitely going to impact the consumer considerably, and the quantity demanded is going to drop drastically. They're not going to want to buy as much of that product at that higher price. And so you can see the quantity 0 here is a big difference between that and quantity 1, as opposed to on the left-hand side chart. So tax incidence, the manner in which the tax burden is divided between the buyers and sellers. If demand is more inelastic than supply, consumers bear most of the tax burden. But if supply is more inelastic than demand, then the sellers bear most of the burden. They'll be losing all those customers. And here we can see elasticity and the tax incidence. And we see a tax wedge. An excise tax, which is a tax on a particular product, like cigarettes, for instance, introduces a wedge between the price paid by consumers and the price received by the producers, obviously, because that tax is going to go to the government instead. The more elastic the demand and supply curves are, the lower the tax revenue. And so here we can see elastic demand and inelastic supply. So elastic demand, as we can see here, because people are pretty price flexible, and you can see that the demand curve has less of a slope. But here we have a steeper slope for supply. So this would be an inelastically supplied product. So when the price changes, they can't really change the supply as quickly. They're not as flexible. And in this case, you can see the size of the wedge, which is shaded in purple. And so the elasticity of demand or supply, if the elasticity is greater, then the tax revenue is going to be smaller. So it doesn't matter which one. If the elasticity or the product is elastic demanded, people are incredibly flexible. Oh, the price has gone up a bunch. I'm not going to buy this. Then the government is going to be able to make enough revenue. That might not be the policy point. I mean, the policy point supposedly behind cigarette taxes, for instance, is to get less people to smoke because it has a huge societal cost on health insurance. It drives up all of our health insurance costs, all of our Medicare costs, all of our Medicaid costs. However, it's also true if supply is more elastic. Look at this one on the right-hand side. Supply in this case is elastic because it is flatter than it is over here. This is inelastic supply. This is elastic supply. So they can improve the supply of this particular product pretty quickly. So if the price goes up, can they produce a lot more cigarettes right away? Yes. In this case, yes. So they have elastic supply. But in this case, notice that the tax wedge is virtually going to be the same size. So the tax revenue still isn't going to be that big as long as there is elasticity in either the demand or the supply of the product. When will the tax revenue be greatest? Obviously, if both of the supply and demand are inelastic. When the demand is more elastic than supply, the tax incidence on consumers is lower than the tax incidence on producers. And so we can see the price for consumers and the price for producers. And we can see the difference between the price that is made, the new price equilibrium because of the tax. We can see there's a difference in the size between the two. And so we have a tax incidence in this case where the demand is more elastic. This is the demand. The curve is flatter, so it's more elastic. Then the tax increase on consumers is lower, which we can see by size here, than it is going to be on producers. So in this case, more of the burden is going to fall onto the producers. And we can see the opposite over here. The tax incident on consumers is going to be larger than the tax incident on the producers whenever the supply is more elastic. So elasticities are often lower in the short run than in the long run. It's important to remember because over time, people will find alternatives. New companies will come up. More substitutes will be found. People won't want to use this as much anymore. So inelasticity fades over time because a product is not going to be as necessary over the long run. That includes supply as well because, it's apples, for instance, they're inelastically supplied because it takes a long time for the fruit to mature on the trees. Or if we got to plant new trees, that's going to take even longer. But obviously, over the long run, then we can supply more apples more readily. And so the inelasticity is going to fade over time. On the demand side of the market, it can sometimes be difficult to change quantity demanded in the short run, but easier in the long run. And on the supply side, producers of goods and services typically find it easier to expand production in the long term of several years rather than the short run of a few months. Because even if it's a product that you can keep pumping out over and over again, if you need more assembly lines or more factories, that's going to take time. In most markets for goods and services, in the short run, prices bounce up and down more than quantities. In the long run, quantities often change more than prices. And so this looks at the responsiveness of demand to price changes for crude oil. And here we can see the horizontal axis has millions of barrels per day. That is the quantity. And then the price. And this is in US dollars on the vertical axis. And so we can see both the supply and the demand of this particular product in the short run and in the long run. So in the short run, we need oil. We need it for plastics. We need it to make gas. We need it for all kinds of stuff. So the demand curve is incredibly sloped here. It's incredibly inelastic. And then the supply curve. Does it take a long time to drill for and find new oil? Yes. So the supply is also inelastic. If the price goes way up on oil, they can't suddenly produce twice as much oil. They can't do that. They have to go out and explore and find it and drill and then work it through the system in order to get it back to the refinery. So the supply is incredibly inelastic as well. In both cases, you can see that the supply is steep. Over the long run, though, this is still going to be the same. It still takes a long time, much longer than the reaction of demand, for supply to catch up to price changes. And so the price or the inelasticity of supply is still going to be pretty great. These slopes are incredibly steep. Demand, though, you can see has started to level off some. So it's not as steep as it was before. It's still probably steeper than most products, but we do have less inelasticity. So this equilibrium marked with an EO is going to be at the point where supply and demand are the same. In this case, we're looking at the original supply curve, SO. The shift of supply from SO to S1 is to the left. And so remember, this is a decrease at all price levels, the quantity produced. For instance, at this price level, maybe we're producing 15, and over here we're producing 10 now. So with even at this, or excuse me, yes, even at the price a little over $5, we're going from 15 down to 10. And so this signifies a decrease in supply. Maybe a country is going to war in the Middle East, and so we can't get too much oil out of it. Maybe there's bad weather on the Atlantic, and the big oil tankers can't transport as much oil. Whatever the reasoning is, supply has dropped at all price levels. So we see the new equilibrium is much higher in price. So this is why in the short run you can see huge changes in the prices of oil and therefore all the products that are made from them, like gasoline. So whenever a hurricane hits the Gulf Coast and knocks out a bunch of oil refineries, this is why gas prices might go up drastically. When there's a war in the Middle East, this is why prices might go up drastically. Over the long run, though, those kind of changes aren't going to have as much of an impact as you can see here. So we can have supply decrease about the same amount, and you can see the price change is going to be incredibly different. And there's also income elasticity of demand. When it comes to income, we look at the percentage change in quantity demanded divided by the percentage change in income. For most products, most of the time, income elasticity of demand is positive. That is, a rise in income will cause an increase in the quantity demanded. That is for normal goods. For inferior goods, that's different, though, because people are going to want less of them as the income goes up. So ramen noodles or hot dogs or other things like that. And then there's cross-price elasticity. The change in the price of one good can shift the quantity demanded for another good. So the percentage change of the quantity demanded of good A divided by the percentage change in price of good B is going to determine the cross-price elasticity. And so that will tell us whether or not these two products are substitutes or are they complements. So whenever we calculate this, the number, if it is positive, then those two goods we know are substitutes. So we can tell if one product can be purchased instead of another. We can tell that mathematically by using this formula, and if the number is positive, then those two products are substitutes. People are definitely going to say, well, if the price goes up on this one, I'm going to buy this one instead. If the number is negative, it means the products are complements, which means that they go together. So we can tell spaghetti sauce and spaghetti noodles, if we use this formula, for instance, taking into account the change in the quantity and change in the price of one or the other, then we can see a negative number, which signifies, in fact, that they are complements. So you can know, if you see the price of one go up, for instance, is it okay for the other one to go up? Or if the price on one goes up and it sells less, is it going to impact the demand of this other product? And so that's something to watch out for whenever you have a product that is reliant upon others, possibly. And of course, there's other things that we can look at: elasticity of wages in the labor supply. Because remember, supply is coming from the people, so that's the percentage change in labor supply divided by the percentage change in wages. And then we can look at the wage elasticity of labor demanded. So, in other words, the actual purchasing of labor by businesses. They want to go out and hire people. They're demanding the labor. So that'd be the percentage change in quantity of labor demanded by the percentage change in wage. Now, why do this? Well, obviously, because for instance, in supply, if people for a particular type of occupation, if the wage goes way up and they're more likely to jump into that occupation no matter what it is, then it means that it has elasticity, that people are incredibly flexible. However, no matter what the wage is, if people don't want to do it, then the labor supplied is inelastic. And the same, we can look at it from the demand perspective. This would be from businesses that are hiring. The same is true here. If the wage changes a lot, if people want a lot more money, if they demand a higher price, and the employers can't do without. They can't just say, no, we're just not going to hire anybody anymore for this. And they can't do that if they have to hire people. They have to hire people in order to work in this industry. They can't go without. They have to go out and purchase that labor no matter what the price is. Then we can say that it is inelastically demanded. And why does that matter? Well, if you want to get a higher wage, obviously it is an advantage to you if your job has a high level of inelasticity when it comes to the demand for your labor. And we can see it for other things too. You can apply it to all kinds of stuff. Interest rates, for instance. And then this comes from the text, and it brings up the case of Netflix. So we can just look at this and see that they had 24.6 million subscribers. They had a 60% increase, looked at 810,000 consumer loss. So it might appear there that over the short run, there might be elastic demand, but over the long run, they caught up. And so you might say it's inelastic, but that isn't taking consideration that people often have subscriptions for entire years. And so that might be a little conflated to look at it from that perspective. What it is important to look at, though, is something else. Isn't necessarily the quantity demanded from year to year, but the growth rate that was happening. So an average per quarter growth of about 1.6 million people, that was less, and that's after the price change, than the 2 million per quarter they were seeing originally before they raised their prices by 60%. So when we look at the quarterly growth, we can see that in fact it is a more elastic product. People are not willing to sign up for it as much anymore because of the price change. So where did Netflix make a bad judgment? Well, they should have checked the cross price elasticity, and they should have remembered there are other alternatives like Vudu, Amazon Prime, Hulu, Redbox, and they misjudged how loyal people were. So they should have taken those other types of equations into consideration.